Up to now, we've only described atoms as a basic unit of an element, as the smallest amount of matter that could still maintain the properties of a particular element. But we can describe them in much greater detail. The idea of the atom actually traces all the way back to ancient Greece, but it has advanced considerably in the past few hundred years, to the point that we can now put together a relatively comprehensive atomic theory. As we already know, each element is made up of a different type of atom. However, we can now add what distinguishes one type of atom from another. All atoms are actually made of several smaller subatomic particles, and the number of each of these subatomic particles that a particular atom has decides what type of atom it will be. There are three types of subatomic particles in each atom: protons, neutrons, and electrons. Protons and neutrons are found in the center of the atom, and together are called the nucleus. The nucleus accounts for nearly all of the mass of the atom. Protons have a positive charge, and neutrons have a neutral charge, so the nucleus as a whole has a positive charge. Outside the nucleus, the electrons orbit in an area called the electron cloud. Electrons are much smaller than protons and neutrons, so this cloud has almost no mass. However, the electrons each carry a lot of energy and move very fast, so they take up a lot of space. This means that while most of the mass is in the nucleus, most of the volume is occupied by the electron cloud. Electrons have a negative charge, balancing out the positive protons. Outside of some compounds, atoms have the same number of electrons and protons, which gives them a neutral charge overall. Since neutrons don't have a charge, they don't contribute to chemical reactions as much and can vary from one individual atom to another. It took a while for us to understand the composition of an atom this well. The first atomic theory was proposed by John Dalton in the late 1700s, after observing that elements combine in certain proportions when forming compounds. He didn't know the inner working of an atom, but he proposed the following theory based on what he did know. First, he said that all substances are made of atoms, and that atoms are small particles that cannot be created, divided, or destroyed. Second, he said that atoms of the same element are exactly alike, and atoms of different elements are different. And finally, he noted that atoms join with other atoms to form new substances. His theories were actually very close, but later research required a few changes to be made. In 1897, John Thomson discovered that atoms had negatively charged particles inside them. He had discovered electrons. In 1909, Ernest Rutherford discovered that atoms had to be mostly dead space with negative particles, electrons, distantly surrounding a dense positive nucleus. And then, in 1913, Niels Bohr proposed that electrons orbit the nucleus at varying energy levels. Bohr's theory has since been revised to say that electrons roughly move in patterns called orbitals, which coincide with their energy level, but that their exact position cannot be determined. Altogether, these discoveries have allowed science to alter John Dalton's theory and shape our modern theory. Another addition to Dalton's theory involves the number of neutrons in the nucleus. All atoms of a particular element have the same number of protons in their nucleus, but the number of neutrons can vary from one atom to the next, giving different atoms slightly different masses. The different mass versions of an element are called isotopes. Most elements have multiple isotopes, some of which are radioactive. This doesn't mean that they're explosive or dangerous, it just means that they decay over time. Let's look at carbon as an example. Most carbon atoms have a mass of 12 ANU. However, some have a mass of 14. Carbon-12 atoms have 6 neutrons, while carbon-14 atoms have 8 neutrons. Carbon-14 is a radioactive isotope, which means that it slowly decays into other forms over time. Carbon-12, though, is stable, so it maintains its composition. With all these revisions taken into account, we can now put together a more complete atomic theory. All substances are made of atoms, which in turn are made of smaller particles called electrons, protons, and neutrons. Atoms can be divided or combined, though, but it is difficult, through the processes of nuclear fusion and nuclear fission. Atoms of the same element will all have the same number of protons and electrons, but the number of neutrons, and as a result the mass, may vary. We're talking about isotopes there. And finally, atoms do join with other atoms to form new substances, that is, forming compounds.